Viewers, you are watching Mathematics channel number Collage. For checking linear dependence of vectors, we write them as k1x1 plus k2x2 plus k3x3 equals 0 and name it 1. That will become k1 vector x1 plus k2 vector x2 plus k3 vector x3 equals 0 vector. Remember here k1, k2, k3 are all non-zero. We get k1 plus 3k2 plus 2k3 equals 0. 3k1 minus 5k2 minus k3 equals 0. 4k1 plus 2k2 plus 3k3 equals 0 and 2k1 plus 6k2 plus 4k3 equals 0. Now we will write them in the matrix form. 1 3 2, 3 minus 5 minus 1, 4 2 3, 2 6 4, k1 k2 k3 equals 0 vector. We will convert this coefficient matrix into row echelon form as follows: r2 minus 3r1, r3 minus 4r1, r4 minus 2r1. That will make all elements below this leading one 0. So 3, 4 and 2, all of them will become 0. So we write 1, 0, 0, 0, 3, 2 as it is, minus 14, minus 7, minus 10, minus 5, 0, 0. K1, K2, K3 equals 0 vector. Next we write minus 1 by 7 R2 and minus 1 by 5 R3, so that second row will be 0 to 1 and third row 0 to 1. Rest will be same. Next we will perform R3 minus R2 to make these two elements 0. So we write R3 0 0 0. Rest of the things will be same. Now the coefficient matrix is in the row echelon form, from which we can write two equations as follows: k1 plus 3k2 plus 2k3 equals 0, 2k2 plus k3 equals 0. Here rank of the matrix is 2 and there are 3 unknowns. So 3 minus 2, that is 1. We will express k3, k2, k1 in terms of a single parameter t. Hence we write k3 equals minus 2t. T is parameter. That gives, from this second equation, k2 equals 2t upon 2 t, and k1 from this first equation minus 3t minus 2 times minus 2t, which will be t. Here k1, k2, k3 are not all zeros. Using these values in equation 1, we can write tx1 plus tx2 minus 2tx3 equals 0. That is x1 plus x2 minus 2x3 after dividing by t, which we can write as x1 equals minus x2 plus 2x3, which is x1 as a linear combination of x2 and x3. Here rank of coefficient matrix R is 2 because there are two non-zero rows. Therefore we can write x1 as a linear combination of two vectors x2 and x3. Therefore we can express x1 in terms of two linearly independent vectors x2 and x3. Moreover, k1, k2, k3 being not all zeros, given vectors are linearly dependent. To examine linear independency of vectors, we will consider as usual the equation k1x1 plus k2x2 plus k3x3 equals 0, where k1, k2, k3 are constants. k1 vector x1 plus k2 vector x2 plus k3 vector x3 equals 0 vector. From this we can write 3k1 plus 2k2 plus 4k3 equals 0, k1 plus 2k3 equals 0, k1 minus k2 plus k3 equals 0. In the matrix form 3 2 4, 1 0 2, 1 minus 1 1 into k1 k2 k3 equals 0 vector. To bring 1 in place of this 3, that is leading 1, we will perform r1 interchanging with r3, 1 minus 1 1, 1 0 2, 3 2 4. Rest will be same. Now to make this 1 and this 3 0, we will perform R2 minus R1, R3 minus 3R1 so that these two elements become 0 below this one, and second row 0 1 1, third row 0 5 1, rest being the same. We can make this element 0 by performing R3 minus R2. So R3 becomes 0 4 0 and rest being the same. Now the coefficient matrix, this is in the row echelon form, from which we can write k1 minus k2 plus k3 equals 0, k2 plus k3 equals 0, and 4k2 equals 0. This gives k2 equals 0. Using in this equation k3 equals 0, and using k2 and k3 in this equation k1 equals 0. Now since k1, k2 and k3 all zeros implies given vectors are linearly independent vectors. This question is not different from the earlier ones. So we will start as usual by considering the equation k1x1 plus k2x2 plus k3x3 equals 0, where k1, k2, k3 are constants. k1 vector x1 plus k2 vector x2 plus k3 vector x3 equals 0 vector. We name this 1. We can write k1 plus 3k2 plus k3 equals 0. 2k1 minus 2k2 minus 6k3 equals 0. 3k1 plus k2 minus 5k3 equals 0. In the matrix form 1 3 1, 2 minus 2 minus 6, 3 1 minus 5, k1 k2 k3 equals 0 vector. With the help of this leading one, we will make this 2 and this 3 0 by performing operations R2 minus 2R1, R3 minus 3R1. These two elements 0, 1 3 1. Second row 0 minus 8 minus 8. Third row 0 minus 8 minus 8. Rest is the same. Next we will make this minus 8 and this minus 8 0 by performing operations R3 minus R2. That gives third row 0 0 0. Second row 0 minus 8 minus 8. And rest of the things as they are. Minus 1 by 8 R2. That gives second row 0 1 1, and rest of the things remaining the same. Here this coefficient matrix is in the row echelon form with rank r equals 2 and number of unknowns 3, which gives non-trivial solution. So we have to write the values of k1, k2, k3 in terms of t. Before that we write from this k1 plus 3k2 plus k3 equals 0, k2 plus k3 equals 0. So vectors are linearly dependent. So to write the solution, we will put k3 equals parameter t. Putting in this equation, we get k2 equals minus t, and putting k2 and k3 in this equation and simplifying, we get k1 equals 2t. Putting these values in equation 1, we can write the relation between the vectors as 2tx1 minus tx2 plus tx3 equals 0. After cancelling t, the relation becomes 2x1 minus x2 plus x3 equals 0. Viewers, if you like this video, please like, share and subscribe this channel, Number Collage. See you in the next video. Until then, keep watching Number Collage. Thank you.